Today we will discuss about the different positions of image formed by a convex and concave lens. Then we will study the nature of the image formed by that type of lens. In the previous class already we discussed about the rules for the image formation. The three rules were, first one was, if the incident ray is parallel to principal axis, then it will refract through the point F, which is your focus. And second rule was, if the incident ray is passing through the focus, then the refracted ray will be parallel to the principal axis. And third rule was, if the incident ray is passing through the optical center, then it will be undeviated. Now, by applying these three rules, you can apply any two rules, because we need two refracted rays and their intersecting point. At that intersecting point, our image will be formed. So, first situation for your convex lens. Suppose the position of the object is between O and F. This is your convex lens. O is the optical center and XY is the principal axis. These are your focus. Now, place the object between O and F. So, suppose AB is an object which is placed between O and F. Now, apply any two rules. First rule, if the incident ray is parallel to principal axis, then it will refract through the point F. Second, if the incident ray is passing through the optical center, then it will undeviate. Remember one thing, whenever you want to draw the diagrams or mark the position of the image, then use scale and pencil. Now, mark two refracted rays. This is your one and this is your two. They will never intersect each other. If you extend them, then they will intersect at this point. That means in this diagram, or when the object is placed between O and F, at the time the image will be formed on the same side of the object. That means, in other words, you can say that the nature of the image is your virtual and erect. Suppose A dash B dash is the image formed by the convex lens. So virtual means the image is formed on the same side of the object. If you mark the size of the object AB and the size of the image A dash B dash, then it is clearly observed that the image is here magnified. Magnified means enlarged image. So second property you can say the enlarged image is formed in this situation. Now, what is the position of the image? Position of the object is between O and F, and the position of the image is here beyond F, or you can say कि the image is formed on the same side of the object. Now, second situation. When the object is placed at F, means at focus. This is your convex lens, this is optical center, and draw the principal axis, which is your XY. Now place the object at F. So this is your object. Now apply any two rules. I am applying here first rule. If the incident ray is parallel to principal axis, then it will refract through the point F. And second one, if the incident ray is passing through the optical center, which is your O, then it will undeviate. Now mark two refracted rays. This is your one and this is your second refracted rays. What is the nature of the refracted rays? These two are parallel to each other. Parallel to each other means the image is formed at your infinity. At infinity means at that time the image will be so large, or you can say कि the image will be enlarged as compared to the object. Clear? So now tell me what will be the position of the image. Position of the image, you can say at infinity, or you can say कि the image is formed on the other side of the object. And nature of the image, other side of the object means nature of the image will be a real and inverted and enlarged also. Now come to the next position. When the object is placed between F and 2F. 2F means 2 times of the focal length. So first draw the convex lens. O is the optical center and XY is the principal axis. This is F, this is 2F. Similarly, this is F, this is 2F. Now place the object between F and 2F. Suppose AB is the object which is placed between F and 2F. Now apply any two rules. This is your incident ray which is parallel to principal axis, and this will refract through the point focus. Draw another incident ray which is passing through the optical center, and that will be undeviated. Now mark two refracted rays. They are intersecting at this point. Suppose this point is your B dash. That means A dash B dash is the position of the image. Now, what can you say about the position of the image? This is your 2F and this is the position of the image. That means the image is formed beyond 2F. Clear? And nature of the image. The image is formed on the opposite side of the object. So you can say that the image is a real and inverted. And if you compare the size of the object and size of the image, it is clearly observed that the magnified image is formed in this situation. Now, if the position of the object is at 2F, which is your fourth position. So this is your convex lens. This is optical center, which is your O. Draw the principal axis. F, 2F. F, 2F. Now, place the object at 2F. Means AB is the object. Now apply any two rules. This is incident ray which is parallel to principal axis, and it will refract through the point F. Second, draw the incident ray which is passing through the optical center, means it will be undeviated. Now these two rays will intersect at this point. That means at this point the image will be formed. Suppose A dash B dash is the position of the image. Now, from this diagram, you can say that the position of the image is also at 2F, and nature of the image is real image because the image is formed on the other side of the object. So real and inverted and the same size. Same size means the size of the object and the size of the image will be same. Okay? If you draw with the help of your pen and pencil and scale, then you can clearly observe that the size of both objects and image will be same. Now, the position of the object is beyond 2F, which is your fifth position. So draw the convex lens. O is the optical center and XY is the principal axis. F to F. F to F. Now place the object beyond 2F. This is your 2F. So we can place the object here. AB is the object. Now draw two incident rays, or you can find out two refracted rays. So applying first rule means draw the incident ray which is parallel to principal axis, then it will refract through the point. Focus. Draw another incident ray which is passing through the point optical center, and that will be undeviated. Now mark this point. Means at this point these two rays are intersecting with each other. Or in other words, you can say A dash B dash is the position of the image found by the object when the position of the object is beyond 2F. Clear? Now, what can you say about the position of the image? Between F and 2F. Between F and 2F. And what is the nature of the image? Nature of the image is also found on the opposite side of the object. So you can write down real and inverted, and at that time that is your diminished or small in size. Now this is the last position of the object for your convex lens. Means if the object is placed at infinity. So draw the convex lens. O is the optical center and XY is the principal axis. Now remember one thing. Here the object is placed at infinity. Infinity means at that time the incident rays are coming parallel to each other. So draw the incident rays which are parallel to each other. At infinity. Now, these two rays are intersecting at this point. Suppose the point is your A dash B dash. That means A dash B dash is the position of the image formed by the object when the object is placed at infinity. At the time the image is formed at your focus. So we can write down the position of the image is at F. And what will be the nature of the image? When the object is placed at infinity, the nature of the image is a real, inverted and diminished. Real means the image is found on the opposite side of the object. That's why the nature of the image is a real, inverted and diminished. This is all about a formation of image or different positions of image and nature of the image formed by a convex lens. Now we will discuss about the positions and nature of the image formed by a concave lens. So if the position of the object is between optical center means O and infinity. So first draw the concave lens. This is your optical center and XY is the principal axis. Now place the object between optical center and infinity. This is your optical center. So suppose this is the position of the object. Now apply two rules so that we can find out the intersecting point, and at that point the image will be formed. So applying first rule, draw the incident ray which is parallel to principal axis and that will refract through the point F. But in case of your concave lens, the ray will diverge. This is your refracted ray and this will refract through the point F. Now apply another rule. Draw an incident ray which is passing through the optical center and that will undeviate. Now find the intersecting point of these two rays. That means suppose the point is a B dash. So A dash B dash is the position of the image. Or you can say that the image is formed between O and F. And from the diagram it is clear the object and the image both are found on the same side. So you can write down the position of image is between optical center and focus. And nature of the image virtual because same side, and erect. And if you compare the height of the object and image, it is clearly observed that the diminished image is formed here. Clear? Now we are considering the position of the object at infinity for your concave lens. So draw the concave lens. O is the optical center and X, Y is the principal axis. Now the position of the object is at infinity. Infinity means at that time you have to consider that the incident rays are coming parallel to each other. So these are two incident rays which are parallel to each other because the object is at infinity. Now PQ is the incident ray which is passing through the point O, means your optical center, and that will be undeviated. Another incident ray, suppose MN, and it will diverge because we are considering the concave lens or diverging lens. Now mark these two rays. This is 1 and this is 2. So their intersecting point is here. That means you can say the image will be formed at your infinity and the image will be virtual because the image and the object are on the same side of the lens. That's why you can write down position of image is at F, means when the object is placed at infinity, at that time the image will be formed at your focus. And nature of the image, same side, that's why you can write down virtual and erect. And by comparing the height or the size of the object and image, it is clearly observed that the diminished image, or you can say the point sized image will be formed. So this is all about your different positions of image and the nature of the image formed by your both spherical lenses.